Hey guys, welcome to Rotor Riot, and today we're doing a build. We are building the Rotor Riot Spec Quad. This is the drone that all the Rotor Riot pilots are going to be flying on the show to feature the DJI digital FPV system. DJI sponsored this build to help show you guys which components we believe work best with the system. So if you guys are wanting to fly the same drone that you see us flying here on Rotor Riot in HD FPV, you can actually get it pre-built. We offer this as a pre-built quad that you can just pretty much pull out of the box and rip. But if you guys are interested in building it for yourself or learning how to maintain these, we're going to be running through an entire build. So like I said, our build is going to consist of the HD1 airframe, which is going to carry the DJI air unit. Since I'm doing the build, I'm going to be using my own hype train motors, the Ladrib motors. These are a 2306 2650 kV, so lots of power on 4-cell batteries. And then we've got the hobby wing stack. Really simple build. All you guys are going to need is a basic hex driver set. We've got the Rotor Riot quad toolkit that's going to give you every size of driver that you need, and also a soldering iron to connect the motor wires to the ESC, and if you're using the hobby wing stack, the air unit wires to the flight controller. Tweezers and pliers always make things a little bit easier. Let's get into this. The first thing we're going to do is assemble our airframe. We've got all the pieces laid out here. It's a very simple frame. You've got your main plate, your top plate, some arms, and some 3D printed pieces that are specific for mounting the DJI air unit components. We got our included hardware, which is 6 standoffs and screws of assorted lengths. Let's separate out the long screws. I think these are 12 millimeters, and these are the screws that we are going to use to put together the lower sandwich consisting of the main plate, the bottom brace, and the 4 arms. Also, highly recommend using Loctite. While I hate how messy this stuff is, it really does help your build hold together. The order of assembly is that this X-shaped brace is going to go on the bottom, the arms will go on top of that, and then you have your main plate. So the screws are going to feed up through this lower X brace, through your arms, and then thread into the press nuts in this main plate. Be very careful that you install the press nuts on the inside of your drone, so away from the bottom, which is this X brace. So I usually start by just getting one arm, got our 2 millimeter driver, and we're just gonna barely get it in, so it's all really loose. You want these protective tips of the arm ends to face forward and back. That's how you're gonna crash. That's gonna protect your motors. We'll do the other screw on the same arm, also just loosely in there. Getting this sandwich started is kind of the hardest part of the frame assembly because you're trying to handle 3 parts at once. But once you've got it going, it's really easy to take the other arms and just insert them in there. Again, all these screws, you're just getting them loosely in there. And then once we have all 4 arms in place, we'll tighten them all up. All right, we've got all 4 arms in place. Wipe all that excess Loctite off on your pants, or a rag if you got one. And now make sure that you haven't somehow messed this up, but I don't even think the holes will line up. But again, just double check that the points of the arms are supposed to go forward and back, and the press nuts are to be on the inside here. So you should see the press nuts sticking up. All the carbon should be flush against each other. If you've done it the right way, there'll be like a gap. This is how it's supposed to be. And now we'll go around to all 8 screws and crank them down. So next up, we're gonna mount the motors to the arms. All the wires should come meet in the middle, and then we'll install our 4-in-1 and solder up the wires. So these arms are 5 millimeters thick. So to mount these motors, you're gonna need like ideally a 7 millimeter screw. Those are kind of tricky to find. So 8 millimeter screws work really nicely. You just wanna be careful that the screw doesn't go up through the feet of the motor and make contact with the windings. That can short out and ruin your motor. So if you do find that the 8 millimeter screws are a little bit too long for your motor, you can always add a washer to take out some of that length. Thread it into the motor. All 4 motor screws are installed on this motor, and now we're gonna just look closely and make sure that none are touching the windings, and no, they're not even sticking out past the feet. So that's perfect. The other option that you have for mounting these motors is to use these quad skids. These are hard plastic material. They go under your motor here, and I love these things because they let you do skid tricks on the ground. You will insert the screw through the quad skid, up through the arm, and thread it into the motor. So whichever way you decide to mount your motors, just go around and do the other 3 the same way. Now just going around and double checking all the motor screws. There we go, we have all 4 motors mounted to our frame assembly. Next up, we're gonna grab our stack. Let's start with the Hobbywing stack here. This is a really high quality piece of electronics. When choosing a stack to work with the DJI system, one of the most important things to consider is does it have a regulated power supply? If you're running 4-cell battery, you can connect the FPV air unit directly to the battery, but not if you're running anything higher than 4-cell. You can only feed this up to like 18 volts or something like that. So if you're running 5 or 6-cell, you need to have a regulated power supply. But even if you're using 4-cell like I do, I think it's better to use a regulated power supply. It's going to feed cleaner power to the air unit. So I definitely recommend picking a stack that has a good power supply. The Hobbywing stack has a 12 volt 2 amp power supply. So that's maximum of like 24 watts, so you have tons of headroom. You're going to be able to reliably power your air unit using this stack. Another nice thing about this stack is that they give you really nice hardware kit with it, your power lead and connectors of different lengths depending on how you arrange the 2 boards, and we'll get into that. But first, let's just grab our hardware. These long screws are the perfect length for the HD1. You will notice that the holes for the stack are enlarged in the lower X brace and the arms, and typically that's so that the head of the screw fits through and so that you can remove the arms without having to remove the stack. The heads of the screws that come with the Hobbywing stack are a little bit larger so they don't pass through. However, that ends up working out pretty well because they are so long. So we're going to feed the screw through, and the head is going to sit on top of the lower brace, but it's going to be the perfect length for this frame for mounting both of these stacks. You'll see. Now you've got 2 different types of these blue spacers. There's a set of 4 that is threaded, and there is a set of 4 that just slips over it. I like to use the threaded ones first because it will hold all the screws in place and make the build easier. So we're going to thread these little spacers on there. The spacers are textured so you can get a good grip on them with your fingers and then tighten them down with your tool. You don't need to go crazy, you just need it to kind of snug up. Now what we're going to do is drop the 4-in-1 onto these screws. So first, identify the front and the rear of the frame. The side with the extra holes, that's the back. Now let's figure out how we're going to orient this 4-in-1. The default orientation, the way that Hobbywing has it set up, is to have the LiPo pads as well as the capacitor in the rear. So using the default motor mapping, that's how you would position the board. The problem with that though is that our DJI air unit is going to go into the rear. So it would get a little bit tight back there if we had these thick wires running into it as well as this capacitor. So we are going to reorient this board. You could do a complete 180 and have the LiPo pads in the front and then kind of route the wires that way. And that makes for some pretty easy soldering with the motor pads coming out either side. But my favorite way to do it is to actually have the LiPo pads on the side. It allows for some little build tricks that make this a really clean looking build. So there we have our 4-in-1 slid onto the stack screws. Now it's time to solder the motor wires to the 4-in-1 ESC. So the easiest thing to do would be to just run the motor wires straight to the motor pads. But again, things might get a little bit tight in the rear with the air unit being back there. So something that I like to do to prevent that, as well as make this look really nice and clean, is to run the motor wires in the side and turn them around the stack screws so that they will connect like that. So let's tape our motor wires down to the arms to help route everything and again make it all clean and nice. I kind of just hold the wire over the pad that it will be soldered to and then cut the wire. Leave just like a little bit extra. It's better to leave a little bit of slack than cut the wire too short and have things be all tight and run out of room to run the wire. So with the wires cut, now we are going to strip it. You can just use your nail or you can use tools like you're supposed to. Now grab your trusty TS100 soldering iron. What we're going to do is we are going to pre-tin the wires. We are going to pre-tin the motor pads, and then we're going to solder the wires to the pads. Always clean your tip. Some nice high quality solder. It's better to use a higher temperature and hold the iron on the pad for less amount of time than it is to use a lower temperature and have to hold the iron on longer. You're more likely to damage components the longer you hold the iron on the component. There, we've got nice shiny blobs of solder evenly distributed across the pads. That's what we're looking for. Now we're gonna pre-tin the wires. Definitely pull the wires back away from the boards. They're probably naturally gonna be hanging out over the board here, and you don't wanna be holding your iron over the board when you're pre-tinning the wires. You could get like a blob of solder or a stray fleck or something, and if it lands on the 4-in-1, it could cause a short, damage your component. So just pull the wires back so that they're safely away from the circuitry. Now again, hold the iron against the stripped portion of the wire. Just add in some solder. All right, now we've got solder on our wires. We've got solder on our motor pads. Let's solder them together. We use these needle nose pliers here. So to make sure that it routes cleanly, we're gonna grab the inside wire first. Hold the wire on top of the pad and just apply heat and let them flow into each other. You shouldn't have to press down hard, and you shouldn't have to hold the iron on for too long. Just let it all flow nice and cleanly. Look at that, that's beautiful. Now I'll grab the middle wire, same thing. I think I could use a little bit more solder, so I'm just gonna touch the iron and the solder to that blob to try and get some more on top of it. There we go. Then hold it down. Make sure it all flows continuously. There we go, that's what I'm looking for. Look how clean that is, yes. Last one on this motor. All right, we have all 3 wires connected. Just take a close look, make sure that the pads aren't bridged at all, that you don't have any solder connecting. Looks good to me, so let's repeat that same process for the other 3 wires. Now, one more very important thing we have to solder to our 4-in-1 is this battery lead. This one's gonna be a little tricky because it's really thick wires on really big pads, so we're gonna probably just turn the iron all the way up. As far as length goes, I like to just hold the pigtail against the 4-in-1 here. Make sure to line the black wire up with the negative side of the board, and just kind of feel out a good length, knowing that I'll probably strap this pigtail against the side of the battery. Again, too long is better than too short. For scale, I've got my wires cut about that long. That gives you kind of a rough idea. So again, same theory, pre-tin the wires, pre-tin the pads, flow it all together. It's just gonna be a little more time and all the heat we can get. The pad is really soaking up a lot of the heat, so the blob of solder is kind of sitting on the pad rather than flowing into it, so I'm just kind of like slowly spreading the solder across the pad, just kind of small circles, just to get it to actually be soldered onto the pad. So we added a bunch of solder to our wires, but as I look at the other side, I'm seeing that while this side has solder on it, it didn't make it to the other side, so we'll come at it from the other side. And you can hold the iron on the wires for a long period of time without having the same concern as when you're soldering to the board, because you're not gonna fry any components, it's just wire. So the wires are gonna be coming out the side, but we need it to go up toward the top plate, and we're also gonna want it to kind of run along the capacitor that's already installed here. So my boy Jeffrey told me a little trick. Once it's pre-tinned, grab the pliers and kind of pre-bend the tinned section, and then now we'll actually install it like that so that the kind of bends in toward the stack. It's gonna make things look nice and clean. Hold it in position and get all the heat you can. Apply heat. There we go, it's starting to flow. Go. Look at it closely. You want to see the solder flow nice and continuously together. Right now it's at a point where the solder of the wire is like sitting on top of the solder of the pad. That's the worst. That's called a cold joint. So just keep applying heat. Add more solder if you have to. On a pad this big, maybe apply a little bit of pressure, but again, you shouldn't be leaning into it too much. The heat should do the work for you. Now for the negative. Yeah, there's a lot of copper on this. This is a 60 amp ESC, so getting these power leads can be tricky. It just means it's a high quality ESC, but it's kind of a pain. It looks pretty good. Pretty good. Watch out for that. Now we're gonna grab our board and make sure it can still slide on. It's a little bit tight on the negative side, so we're gonna apply some heat, grab our pliers at the base and just kind of tilt it up a little more. There we go. Now our flight controller can slide on nice and easily. I like to take a piece of large diameter heat shrink and secure that capacitor to our leads there. There we go. Again, double check our flight board can install. Before we actually put on the flight board, let's put the air unit on here. So we're gonna do a couple things all at once. We're gonna mount the air unit, the antennas, and the antenna holder. The antennas plug into the back of the air unit here, but first we're gonna slide them into our antenna holder. So grab your antenna and your antenna holder, slip the connector through, and now before you press the lobe of the antenna into the print, make sure that you twist it so that the connector is oriented like so. You want the bend facing toward what's gonna be the front of the drone. And once it's positioned right, go ahead and press it in. Same with the bottom one. There we go, goes right through. Orient your connector. Okay, now get two of your standoffs from your frame kit. Slip those on here. You also have two little sleeves that cover the rest of the standoff there. Now we're gonna mount this to the back, so grab two of these short screws left over from the frame kit, thread it into the bottom of the standoff there. Now get your air unit and some double-sided stick-it tape. Snip off like a square, stick it there. Oh yeah.
Ooh, like a pro.
All right, now we're gonna plug the antennas in and stick the air unit down to the carbon. Gonna insert them, gonna click one into place, niggle the other one. There, you wanna hear a nice click there. We're just pushing on the back of the antenna connectors to make sure they are secure in the air unit. Push the air unit down onto the carbon. There you go. Just hold it for a second. And what you want is the back side of the connector to just be touching or maybe have like a hair of a gap to the 3D printed sleeve around the standoff. And that's nice because in the event of a crash where your antennas get jarred, the connector won't be able to pull out. It's looking great. Camera's all floppy though. Let's go ahead and mount the camera so it's not flopping around. The screws come in the camera there. You need your 1.5 millimeter hex driver. Need two more frame standoffs and you've got camera mounts. Slip those on. They curve up, so they should look like that installed. One of the sides of the camera mount has a recess for the heads of the screws. That's to go on the outside. So there is a specific left and right. Now look at the back of the camera. There's an arrow. You want to make sure that arrow is pointing up. Mount the standoffs with the camera mounts installed to the front of the frame here. Put the camera screws into the 3D printed mount and then mount your camera. I'm just threading them loosely. Now I can set my camera angle wherever I want it. I like about 20, 25 degrees, and then we can tighten them down. Of course, we can change that later if we need to. I've got the wire for the camera running over the 4-in-1 there, and it will be sandwiched by our flight controller. Let's get into our bag of connectors that Hobbywing gave us with our stack. Now the short one's really nice if you have the connectors on the ESC and the flight controller right on top of each other. It'll just go like right there. But because we rotated the 4-in-1, that would put our USB in the rear. So we're gonna reorient our flight controller so that the USB comes out of the side. And that is the normal orientation of the flight controller with the arrow facing forward. But what that means is that your connector on the 4-in-1 is on the side and your connector on the flight controller is on the front. So we need this longer connector. So I'm just gonna insert it into the flight controller. Be very careful you get the orientation right. You don't wanna force it. You could damage the pins. Now I'm going to plug in the 4-in-1 side. The connectors on this Hobbywing stack are the same on either end, so you don't need to worry about a flight controller side and a 4-in-1 side. Just plug it in. There we go. We've got the two boards plugged in. Now we have to grab our other blue spacers. These are the non-threaded ones, so they'll just drop right on. We got our spacers on, we got our boards plugged in. Now I like to try and route this cable cleanly between the two boards. So just hold it down as you slide the flight controller onto the stack screws. By the way, I love that Hobbywing has the soft mount gummies pre-installed in both the 4-in-1 and the flight controller. That's always a pain to do. So they made this really easy. There we go. What did I tell you about the included screws? They are the perfect length for this frame. We've got some blue nuts to go with it. You don't want to over tighten these. You don't want to overly compress the soft mount gummies in the flight controller. So just gently snug them up. Now grab the cable that came with the air unit. We're gonna insert the wires under the antennas and over the air unit like that. Plug this into the back of the air unit. It will only insert in one way. Tool and just push it in there, listen for the click. Now pull the wires through. There you go. Now with the flight controller normally oriented, meaning the arrow is facing toward the nose of the drone, all the pads that you're gonna have to solder to are in the rear of the flight board. So really convenient flight controller to work on for this. So something I like to do to just kind of make getting the lengths right is take out all the slack here, hold the wires over the pads that you're gonna be soldering to, take your tool and just press it down into the crevasse here to give yourself a little bit of slack. Again, always better to have too much than too little. So with some slack built in there, we're just gonna cut across all the wires. Now we're going to split these wires. Just gently split these wires. I like to split them as little as possible to keep it clean. All right, and we'll just strip them all. We are working on much smaller wires than we were before, so we're going to turn down our heat a little bit. We're going to drop it to like 380 Celsius. Add solder to the stripped wires. So now this is going to be the most technical part of this build because you have to get all these different wires on the correct pad. We have a wiring guide available, link in the description. It walks you through this entire build. So if you want pictures and wiring diagrams to go along with this, we got you covered. We'll make it very clear how to do all these connections properly. So we're gonna start with this red wire. That's our power wire. Find the pad that is labeled 12 volts. That's this one up here. Add some solder there. So just hold the wire on the solder, flow it together. Beautiful. All right. Next up, we've got our ground wire. There's one right next to our power wire. And you know what? While I'm thinking about it, look at all these little components on the flight controller. All sorts of places for flecks of solder to get and mess things up. So while I'm thinking about it, here's a good tip. Take some electrical tape and just like lay it on top of the board there. Leave the pads and the labels exposed so you can see what you're doing. But just in case solder goes flying, won't ruin your flight board. All right, these are small wires and small pads, so we want to be quick about this. So just keep a clean tip and just give it a little bloop. Now the white and the gray wires are going to connect to TX3 and RX3. This yellow wire is going to connect to the S-bus pad, which is under the RX3. So we're going to do that one first so that the wires above it don't get in the way. This one's thin enough that I can kind of insert it into the hole. It's kind of the way you're supposed to do these. So the white wire is connected to the pad labeled TX3, and the gray wire connects to RX3. And lastly, this brown wire is a ground for the S-bus signal. So just connect that to another ground pad. So now I'm going to take my tool again, push the slack back down into the crevasse so that the wires are running cleanly across the air unit. And then we are going to wrap some electrical tape around the air unit to hold it down so it's not just relying on the double-sided sticky tape, as well as hold the wires down to the air unit. Make sure that you don't block the SD card slot with your electrical tape, so just push it up front as much as you can. All right, now we can reveal our flight board. Boom. We just need to add the second row of standoffs that we haven't put in yet. Now we've got our top plate. One side's got a beautiful Rotor Riot logo. You know you want to show that off, so put Rotor Riot logo side up. The rear will fit nicely with the 3D printed part. Now we can just run some screws in there. All right, everything should be screwed together. Now, while you've got the driver in your hand, is a great time to run over every screw and double check that you've got it nice and tight. All the screws. Oh, we found a loose one. Not even kidding, there's a loose one. There we go. Totally missed it before. Everything is feeling really snug. Oh, no, another loose one. Try to be careful. You're still gonna miss a few. There's a lot of screws here. We're on to final touches. If you don't use the quad skids that I showed you earlier, the frame does come with these little landing feet. You just peel the backing off and stick to the underside of the arm. That'll give you a little cushion landing. And speaking of cushion, let's put a pad down for the battery. We've got some Grip. This is cut to fit battery pad from God. This stuff is great, super sticky. I use this on everything. Just kind of measure out a little piece that we'll put up there. Nothing too crazy. And then depending on where your battery is going to go, so if you don't run a dedicated recording camera up front, your battery will probably end up in the center. Or if you are gonna run a camera up front, then your battery might get shifted a little more rearward. So we're just gonna stick it right behind the skull. We can add more later if needed or whatever. That should pretty much cover you. Gotta have a matching Rotor Riot battery strap. Just loop that around the top plate. Stick your battery on. There we go. Looking good. Our build is done, but it is not time to put the props on yet. We have to register the DJI components and configure the flight controller. So let's get a computer out. We are going to need our computer, a USB-C cable for the DJI components, and a USB micro cable to connect to the flight controller. So let's start off by activating the DJI gear. We're gonna need the DJI Assistant to FPV series application. There's a bunch of different DJI applications. It can get kind of confusing. So to make sure that you get the right one, go to dji.com/fpv/info #downloads. There will be a link in the description, of course. And right here, you can download the application you need depending on the operating system that you have. We have Mac, so we're just gonna click right here. All right, once you've got your application installed, go ahead and grab your USB-C cable and plug it into the air unit and into the computer. You will also need to power on the air unit. Since everything is soldered up, we can just plug in the drone. Now we just wait for it to register on the computer here. And now in connected devices, you should see DJI FPV Air Unit. Let's go in here. And we have a pop-up to start activation. Once we click on that, we need to log into our DJI account. If you don't already have an account, you can sign up. We've created our account. We could customize it, put in our real name or whatever, but we're good for now. Let's just log in over here. Activation success. Once activated, you will likely be given the option to upgrade the firmware. So let's go ahead and do that. Agree to more stuff. Got to download. All right, update complete. Let's get this unplugged. It's beeping at me. It's upset. It's been plugged in too long. All right. Now you need to repeat that same process for the DJI goggles and the radio if you're going to be using it. Same thing, power on the device, plug it in, and just go through all the agreements and all that stuff, update the firmware. If any of the DJI components are not activated, you won't be able to use them. So with our DJI gear activated, it's time to move on over to Betaflight and set up the actual drone. For our drone, we plug the USB micro connector into the flight controller. Open up our Betaflight application. Of course, link in the description to where you can download the Betaflight configurator. All right, we've got everything connected. This is the Hobby Wing stack, which we installed with the flight controller in the standard orientation, and we can confirm that by moving the drone and seeing that the model all moves correctly. Now the first thing that we're actually going to change is in the ports tab. This is where we're going to tell the flight controller what's connected to it. We've connected the S-Bus wire to the S-Bus pad, which uses UART1. So in the row for UART1, we are going to check serial RX. Remember that only one thing for each UART row can be selected. So UART1 is being used for the serial RX, and nothing else in the other columns should be activated. The other UART we're going to work with is UART3. We soldered the white and gray wires to the TX and RX of UART3, and what that is going to provide for is an MSP connection, and that's going to send data from the flight controller to the DJI system so that you can get information like your battery voltage, and you can even tune things like your PIDs and stuff right from inside the goggles. So this is how the air unit communicates with the flight controller. So in the row for UART 3, we just turn on configuration/MSP. And these are the only two things that you need to change in the ports section. So go ahead and save and reboot. Next, we'll move on to the configuration section. We want to use the Quad X mixer. For ESC, no, not brushed. I don't know why that's the default for some of these. D-Shot 600, all right? Your system configuration, we're gonna bump it up to 8K, 8K. This board does not have a barometer or a magnometer, so we can turn those off. For arming, I like to change the value from the default of 25 to 180, and that's going to let you arm even if your drone is at an angle. So maybe you're on like a hill or you're crashed upside down, you'll still be able to arm your quad. The receiver section, we're gonna let it know that we're using a serial-based receiver, and the receiver protocol that we're going to use is S-Bus. There we go. In other features, we've already got anti-gravity and dynamic filter turned on. You can turn on air mode here, or you can leave it off and set it up on a switch later. We'll just go ahead and turn it on. In this beacon configuration, we're going to check both of these boxes, and that will let our motors act as a beeper if we lose connection or we set up a beeper switch or something like that. So we don't need to install an additional beeper, which is really cool. And I think we're good here. Save and reboot again. Now down in the PID tuning section. This is where you can set the PIDs, the filters, and the rates for your drone. This is actually setting up how it's going to fly, how it's going to respond to the sticks, how well it's going to handle things like prop wash and oscillations and all that stuff. The default settings nowadays are very good. There's always room for improvement, but I'm going to go ahead and leave the default PIDs. The rates, I'll put my rates in. The filter settings, also defaults are good. We can tweak it later if needed, but it will fly well. Other settings, I don't know what the defaults are going to be. It depends on your firmware, but you do not want to have iTerm rotation. We will turn on VBAT PID compensation. So as your battery voltage drops, the flight controller will actually boost up your PIDs to maintain the same level of responsiveness, even though you might have like some battery sag and lose some power. Next up, we'll go into the receiver tab. So it's time to get all the DJI components talking to each other. The first thing you need to do is actually bind the air unit to the goggles. They recommend binding those first before the remote. So let's set the remote aside for a second. We're gonna power up the goggles using a 4-cell battery. Don't go any higher than 4-cell. And we'll plug in our quad, which will power on our air unit. Now, to bind the goggles and the air unit, there's a little button on both components that you need to hit. So we're gonna pick up our goggles here, and where is it? It's right near where the barrel connector plugs in. There's a small red button. You need a little pokey thingy. We'll click that. You should hear a beep. That annoying beep. Now we'll go over to our air unit, and below the SD card slot, there's another button. Click that. All right, and we have bound the air unit to the goggles. All right, and we have video. Next thing we need to do is bind the air unit to the DJI remote. So we'll power on the remote, push the power button, then hold the power button. All right, that's on. To put the remote in bind mode, you push this blank button, the record button, and the right dial all at the same time. So blank, record, dial. All right, we've got a blinking blue light and some annoying beeps. And once again, we hit the small button on the air unit under the SD card. All right, and we have a bind. Now we can look over in our receiver tab back on Betaflight. And yes, we have response from the sticks. What we need to confirm is that all the directions and travels are correct. So when throttle is all the way down, throttle should be down at 1000. When it's all the way up, the throttle bar should go up to 2000. Looking good. Yaw, when we move the yaw stick to the left, that bar should go to the left, down to 1000. Yaw to the right, up to... Oh, that's why you don't oh, guys, yeah, never do configuration with your props on, because the default setting is to arm with a stick position, which I hate. I wish Betaflight didn't set it up like that. We haven't set up an arming switch yet, so that could have been bad. Heads up, I think I've made that mistake before on build videos. All right, the roll left, bar goes down to 1,000, roll right, bar goes up to 2,000, and lastly, pitch. When you pitch down, bar goes down to 1,000, and when you pitch up, it goes up to 2,000. Everything's looking good. If you have the wrong channel order, you can select a different channel map within Betaflight. And if the directions of one of the channels needs to be reconfigured, you can actually do that in the DJI goggles. But by default, everything works. I do like to change some of these values here. If I lower this low threshold, it gives me a little more resolution in the throttle at the bottom end. And same with the high threshold, 1995, cool. Things are looking good here. Now let's go over to the mode section, and this is where we can fix that problem. For arm, we're gonna set our arm switch. I like to use this switch up here in the middle position, that's arm. Now we could put angle mode on a switch if we want. When this other switch is in the down position, the quad will have auto leveling. I like to have auto leveling available for like panic scenarios or things like that, but I do fly around in rate mode. And to be in rate mode, just have the switch away from angle mode. Beeper, let's set up a beeper. We'll assign the beeper to this switch in the middle position. Okay, and the last thing, of course, we gotta have flip over after crash. It's known as turtle mode. We'll use the same switch as we used for the beeper, but we'll put it all the way down. There we go. That's all we need to do here. We need to test, does the beeper work? There we go. Now we go to the motors tab. And we're gonna find that the motors probably don't spin the right direction, and they are definitely out of order because remember, we reoriented the stack from the default position. We have to check this box. It says, I understand the risks, and the props are definitely off. We talked about that earlier. And when we spin up motor 1, the motor that's labeled as 2 actually spins. So motor 1 is outputting on 2, 2 is gonna be outputting on 4, 3, it's rotated 90 degrees. So we need to go into the CLI and change the motor mapping. So in the CLI command, we are gonna type in resource, hit enter, and this is gonna output all of the resources, all the outputs of the board. The ones that we are concerned with are up at the top, motors 1, 2, 3, and 4, and we can see their outputs. Now, we need to switch them around a little bit. So let's copy these resource outputs for motors 1, 2, 3, 4 into a text file, and let's move some things around. So default layout is like this, where motor 4 is in the upper left corner, but we have rotated it 90 degrees counterclockwise. So our new layout is going to be like 2, there we go. So now for each of these numbers, we'll put the output code. So for 2, we'll put B01. Okay, now we've got the output codes in the right position, and let's put the correct motor number next to it. Now we can use this to create our new motor map. So we're gonna take these codes in the new order and put it into the resource command. So for 4, we're gonna put B01. So we'll change this to B01. For 2, we'll put B00. There we go. For 3, A02. And for 1, A03. Now we need to put all 4 of these resource commands into the CLI. If that was confusing, don't worry. This is the most annoying part, but we have it figured out for you. Here are the 4 codes. If you're following along this exact setup, we figured it out for you so you can put in these exact commands, and we have them all spelled out in the build guide document that I mentioned. Again, link in the description. So you should only have to do this process if you're using another stack. All right, we've got our commands. Let's go ahead and put them in one by one. Paste it in, hit enter. Okay, now that we've put in all 4 of our resource commands, we just type in save and hit enter. We'll get another reboot. And now we can go back to the motor tab to confirm that we have the motors outputting how we need them. So we'll check this box again, and when we spin up motor 1, we need the lower right motor to spin up, and there we go. We'll check 2, yep, 3, and 4. Everything is looking good. The other thing we need to do though is check the motor directions. If you look at the diagram they show you in Betaflight, the front 2 motors are supposed to spin inward, and the back two motors are supposed to spin inward to the rear. We've got the props off, so we can just lightly touch the bell to see what direction they're spinning. Motor 1 is incorrect. Motor 2, also incorrect. What we need to do is we need to go into yet another application. I know, it's annoying. So we'll disconnect from this and we'll open up the BL Heli 32 suite. We can click here to read our setup. Okay, you can use this configurator to flash your ESCs to newer firmware and change settings in the ESCs if that's something that you want to do. But really all we need to do is change the directions of motor 1 and motor 2. So we will right click on motor 1 so that only that is selected. Click up here to make that reversed. Hit right setup. And we will go over to motor 2 now. Just right click there, hit reverse there, hit right setup. All right, now let's reconnect to all of our ESCs. Go over to the motors tab and we can spin them up in this application as well. We check this box just like in the Betaflight application and we'll just spin them all up. Motor 1 going the right way, motor 2, yep, motor 4, and motor 3. Everything is good to go. While we're in here, there are some ESC settings that I like to change just to make things a little bit smoother. You don't have to do this, but we're in here anyway. Read the setup. Okay, I like to set motor timing to auto. We'll set PWM frequency to the max, which is 48, and we'll turn brake on, stop, on. You don't need to do those things, but I like the way it makes the ESC behave better. So right setup, got our confirmation, and guys, that's it. We have set up our drone. We can actually put the props on this now and fly it. I know this setup process can be really intimidating, but if you just follow all the steps that we laid out, you'll get through it. If you don't want to deal with this building and the configuring, we do offer this build pre-built for you at the Rotor Riot store so that you can just pull it out of the box and enjoy flying. The only thing that you'll have to do yourself is activate your DJI gear and link the air unit to the goggles and remote if you have one. I do think building can be fun, and if you just follow all the steps that we explained in this video, you should be able to do it all yourself. But of course, the best part is actually getting out and flying. HD FPV is an awesome experience. So I'm gonna get some props on this thing and we are going to rip it up. Thank you guys for checking out this video. Make sure to subscribe to the Rotor Riot channel. I'm Ladrib and I look forward to seeing you on the next episode of Rotor Riot.